So, good morning. So we shall now do some introduction. This is our first topic, our first lesson for this unit. So we shall start the topic number 1. So our topic 1 will be portfolio theory. Portfolio theory and the capital asset pricing model and the capital asset pricing model. So our topic is supposed to be portfolio theory and capital. So capital assets is the same as capital. So you can now have that topic as our topic number 1, the portfolio theory and the capital asset pricing model. Portfolio theory and the capital asset pricing model. So we start the first part, which is portfolio theory. So we can now have a subtopic as the portfolio theory. We can now have so the topic is portfolio theory and the capital asset pricing model. So now we start the first part, which is going to be the portfolio theory. So let us now start with the portfolio theory. So we start with the first subtopic as the portfolio theory. So let us now introduce something brief about what we mean by the portfolio theory. Let us now introduce what we mean by the portfolio theory. So we can summarize that a portfolio in financial terms, refers to a portfolio in the financial terms refers to a collection of the investment securities. It refers to a collection of the investment securities, with an aim of minimizing the risk. It refers to a collection of investment securities with an aim of minimizing the risk. There are normally 2 types of the risks facing the company. Number 1 will be financial risk. Under the financial risk, we note that this is the risk associated with the use of the borrowed funds. It is the risk associated with the use of the borrowed funds. In the company's capital structure. So that's now number 1, financial risk. Number 2 will be business or operating risk. Business or operating risk. So under the business or operating risk, we also note that it refers to the fluctuations. It refers to the fluctuations. It refers to the fluctuations in the company's earnings. It refers to the fluctuations in the company's earnings. In the company's earnings, due to the nature of the industry. Due to the nature of the industry, due to the nature of the industry where the company is operating, due to the nature of the industry where the company is operating, nature of the industry where the company is operating. Then we continue by noting that it is also known as total risk. It is also known as the total risk. It is also known as the total risk because it is a combination of, the systematic and unsystematic risk. It is the combination of the systematic and unsystematic risk. Systematic and unsystematic risk. It is a combination of the systematic and unsystematic risk. It is a combination of the systematic and unsystematic risk. So let us start with the A, systematic risk. We start off with A as the systematic risk. We start off with A as the systematic risk. So under the systematic risk, we summarize that it is a business risk. It is a business risk which cannot be eliminated. It is a business risk which cannot be eliminated, or diversified, which cannot be eliminated or diversified, which cannot be eliminated or diversified, or minimized, by holding a portfolio, or minimized by holding a portfolio, or minimized by holding a portfolio, or minimized by holding a portfolio. Then we continue by noting that the fluctuations in the company's earnings, is due to the factors. The fluctuations in the company's earnings is due to the factors that affect all the companies in the industry. It is due to the factors that affect all the companies in the industry. It is due to the factors that affect all the companies in the industry. Factors that affect all the companies in the industry. Although some companies are more affected than others. Although some companies are more affected than others. The others. So that's now for systematic risk. We got number 2 as unsystematic risk. We also check the next one as the unsystematic risk. So under the unsystematic risk, we also summarize that this is the business risk. This is the business risk that can be eliminated. It is the business risk that can be eliminated, or minimized, or minimized, or minimized, or diversified, by holding a portfolio, or diversified by holding a portfolio, or diversified by holding the portfolio. Then we continue on the same by noting that the fluctuations in the company's earnings is due to the factors. The fluctuations in the company's earnings is due to the factors. The fluctuations in the company's earnings is due to the factors. Is due to the factors which affects a specific company in the industry. Is due to the factors which affects a specific company in the industry. It is due to the factors which affect a specific company in the industry. Due to the factors which affects a specific company in the industry. Then a new paragraph, not that. The business risk can be represented. The business risk can be presented using a diagram as follows. The business risk can be presented using a diagram as follows. Can be represented using a diagram as follows. Can be represented using a diagram as follows. So this is now how we can present the business risk. So this side we have risk. This side we have number of the securities. Number of the securities forming the portfolio. I just have it as number of the securities. So this part is the y-axis, this is the x-axis. So this one is unsystematic risk. This is not the systematic risk. So you can summarize them in that order. You can be able to present it in that one. So if you want that, what you do, you will add back one, and then you write it. So, y3 x squared. The value you push add back one. You have to go back one. Then divide this by this part. So we can now have a subtopic as measures of the relationship between security returns. We can now have a subtopic as measures of the relationship between security returns. Measures of the relationship between the security returns. Measures of the relationship between the security returns. So under that, we can summarize number one. We start with number one. Number one will be covariance. So number one will be covariance. So the first one will be covariance. So number one will be covariance. So under the covariance, we note that it indicates whether there is a positive or negative relationship. It indicates whether there is a positive or negative relationship. It indicates whether there is a positive or negative relationship. Positive or negative relationship between the returns of the securities. Positive or negative relationship between returns of the securities forming the portfolio, between the returns of the securities forming the portfolio. Then you continue on the same by noting that it does not give the extent. It does not give the extent of the positive or negative relationship. It does not give the extent of the positive or negative relationship. It does not give the extent of the positive or negative relationship. It does not give the extent of the positive or negative relationship. It does not give the extent of the positive or negative relationship. It does not give the extent of the positive or negative relationship. Then we continue, but it can be expressed as follows. So it can be expressed as follows. So to get the covariance between, let's say, security X and Y, covariance between security X and Y, we simply get the summation from the first observation to the last. So you simply take the returns of X minus expected return for X, then return for Y minus expected return for Y. Then you will be multiplying by the probabilities in that manner. So when you want to get the covariance between security X and Y, we shall simply get the summation from the first to the last. So we get the returns of X minus expected returns for X. Also return for Y minus expected return for Y, then also multiplied by the probability for that. So there's a question I was able to send to your group today. There is a question I've sent to the class group today, which has that information. So that question is for the sitting of November, not November. It must be in the sitting of, sorry. So that question should be in the sitting of November 2019. November 2019, question 3, part B. November 2019, question number 3, part B. Question 3, part B. So that question I've sent to the group, but they will be sending you the past papers. They will be sending you the past papers by the course of the day. So I will go through the question. Those who are online, check in the class group. I've sent that question. I've sent the question. So the question is supposed to read that Duncan Kipchumba has an investment capital of 1 million shillings. He wishes to invest the fund in 2 securities, that is X and Y, in the following proportions. So 200,000 in security X and 800,000 in security Y. So The return on these two securities depend on the state of the economy as shown below. The return on these two securities depend on the state of the economy as shown below. So they were able to give you state of economy where we have boom, normal, and recession. They gave you probability, returns on security X, and also returns on security Y. So required, Roman letter 1, expected return of the portfolio. Roman letter 2, correlation coefficient. So before you get the correlation coefficient, you must first get the covariance. And also before you get the covariance, we must compute the expected returns. So we start in the Roman letter 1, how to get the expected return on the portfolio. How to get the expected return on the portfolio. So to get the expected return of the portfolio, we need to calculate expected return for each. We need to get the expected return for each. So we start with the X. We compute expected return of security X. So to get the expected return for X, also get the summation from the first observation. So there were 3 of them. So returns of X multiplied by the probability for each. The first return for X, it is 18. It is 18. The probability of it occurring is 0.4. Then we add. The second one is 14. The probability of it occurring is 0.5. The last one is 12. The probability of it occurring is 0.1. So when you add them, they will give you expected return for X. Then you'll also compute expected returns for Y, where we also get the summation. There are 3 observation return for Y multiplied by the probability for each. The first return for Y is given as 24. So you take 24, also by 0.4 like that. Then we should also be required to take 22, also multiply 0.5. Then also take 21. We multiply by 0.1. So that will give you expected returns for each. We compute that we get expected returns for each one of them. So you give me the figures, those who are online, you compute, give me the values. So you compute, you give me the values. The first one is 15.4. 15.4. How about the second one? $22.7. So that was the expected return for each. But the question wanted expected return for the portfolio. So to get expected return of the portfolio is the same as the weighted average. It's the same as the weighted average. It's the same as the weighted average, whereby you get the weight of X multiplied by expected return for X. We add the weight for Y, expected return for Y. So Weight for X, they had said that in X, they were investing 200,000. So 200,000 is the same as 0.2 million. Then total amount is 1 million. Then multiplied by expected return for X, which was 15.4, we add the weight for Y. The amount invested in Y was 800,000. It will be 0.8 millions. We also divide by the total, which is 1 million. So you multiply by 22.7. So you add them together. Remember, this is the same as 0.2 multiplied by 15.4. Then also you add 0.8 multiplied by 22.7. So you combine them together, they will be in a position to give you expected return of the portfolio. After getting the return for each, we now combine them to give us the total for the portfolio. So,
21.
We get 21.4. 21.24 like that. Yeah, those who are online, please, you also compute. You also send me your answers to know whether they are correct, so that we compare. We compare them to see whether they are correct. So that is the Roman letter 1, how to get the expected return for the portfolio. So after getting the expected return, we now compute the covariance because we wanted to see how to get the covariance. After calculating expected return for the portfolio, we also need to come up with the covariance. We now need to come up with the covariance. We should also be able to compute the covariance. We should be in a position to get them covariance. So covariance between X and Y. Covariance between X and Y. We had said that it is the same as the summation from the first to the last. So there were 3 observations. Return for X minus expected return for X. Then return for Y minus expected return for Y. Then you multiply by the probabilities and multiply. So the first return for X, remember it was 18 minus expected return, which was 15.4. Then the first one for Y, it is 24 minus expected return, 22.7. The probability of it occurring is 0.4. We go to the next one. This one is 14 minus 15.4. Then the other one is 22 minus 22.7. Probability is 0.5. Then the last one is 12 minus 15.4. Then the other one is 21 minus 22.7, then 0.1. So you add them together to give you the covariance. We add them together to give you the covariance. So when you add, we should be able to get the covariance.
Okay, so you have an example. Example 1. So we are going to define 3, 1, and 2. The value of x, the straight x, okay, 3, 1, 2, value of x. So, solution.
2.07.
2.07. So that is now how to get the covariance. So that was the measure number 1. That was our measure number 1 as the covariance. So we got the measure number 2. So we are still writing the notes. So the measure number 1 was the covariance. So this is how to get the covariance. So we got the measure number 2, which should be correlation coefficient. Number 2 will be correlation coefficient. The measure number 2 will be correlation coefficient. The correlation coefficient. So under the correlation coefficient, we also summarize that. We also summarize that. It indicates the extent of the positive or negative relationship. It indicates the extent of the positive or negative relationship. It indicates the extent of the positive or negative relationship. It indicates the extent of the positive or negative relationship. And it is expressed as follows. 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 So when you want to get the correlation coefficient between x and y, it will be equal to covariance between x and y. We divide by standard deviation of x multiplied by standard deviation for y. So when you want to get the correlation coefficient between x and y, it will be equal to the covariance between x and y divided by the standard deviation for x multiplied by the standard deviation for y multiplied by the standard deviation for y. So we have already computed the covariance. The only item we don't have is the standard deviation. So we now get the standard deviation of x. So we get the summation from the first to the last. So return for x minus expected return for x. So the difference we normally square, we multiply by the probability. So the first return for x, we know it was 18. Expected return was 15.4. So that difference you square. The probability for the first one was 0.4. Get the value for that. We got to the second one, it was 14, we minus 15.4, also square. The second probability was 0.5, we get the value for that. Then the last one was 12, we minus 15.4, we square. The probability is 0.1. So when you add them, you get the square. That will be able to give you the standard deviation for x. Get the total, get the square root to give you the standard deviation for x. You will also compute the standard deviation for y. You will also be required to get the standard deviation for y, also from the first to the last. So you take returns for y minus expected return for y, you square, also multiply the probability, then we come up with that. So the first return for y was 24 minus expected return 22.7, we square, probability is 0.2. The next one is meant to be 22, also minus 22.7, we square, 0.5. Also 21 minus 22.7, we square, 0.2. So you also get the square root for that. So to give me the standard deviation for the two.
So there we can work here. Without substitute there. So is that by using the value of I whatever we take out of B, but 4 times B. So we can go back to then we say minus. Now, divided by 3 as 4 times 2 as 4 times 2. There you will see. And that's final results. 9 plus 12 minus 2 plus 7 minus 8. The final answer is there for B. Final answer. Example B now. Example B. Example B. Example B. Example B. Integral C back. Or x plus bx squared minus a is x. Integrate between 5 or x squared minus 7. Solution. So the solution, we say area equals 4x cubed 1 plus 1 divided by b plus 1 plus bx squared 1 plus 1 divided by 2 plus 1 minus 10x equals 0 1 plus 1 divided by 0 plus 1 0 plus 1
So after computing the standard deviations, we can now come up with the correlation coefficient. We can now get the correlation coefficient. We should be able to get the correlation coefficient. So to get the correlation coefficient, covariance was 2.1. So covariance was 2.07. So standard deviation for x, you are getting it here. When you round it off into 2 decimal places, and is it the square root? No, but the square root. You need to get the square root of that here. You need to get the square root of that value. It should be 2.0. 2.42. Then how about the one for y? 1.21. When you get the square root.
1.5 minus 3. Then minus 3.4
and remaining 0.6.
Like that?
0.6.
Although online I try to compare figures, so I'm not able to compare. Those who are online,
But I don't have the option.
don't have the option of the square root. So you said it is 1.21. That was the variance.
So we have to do the square.
So when you compute the square root, this one should be 1.1. So this one should be 1.1. Because what we have there is the variance. So this other one was which figure?
The other one is 4.84.
4.84. So to get the square root for that is 4.84. So this one should be 2.2. This one should be 2.2. Because what you are getting were variances. So after getting the variance, you get the square root for that. Then now that should be able to give you the standard deviation. So what you are calculating were basically the variances. Then you need to get the square root to give you the standard deviation. So now after that, now our correlation coefficient should be able to give us so this one should finally give me a value of 0.8. Without that figure of the covariance. the second one is 49. 114. Minus. So,
last one, integrate 4 to 10 or 6x squared 4x cubed minus 5
2.4. So this value should be 2.42. Should be 2.42 like that. So that we now adjust. So it's 2.42 divided by 2.2 multiplied by 1.1. So to be able to give you a value of 1. So that figure should be +1. So that was meant to be the Roman letter 2, the correlation coefficient. The correlation coefficient between security X and Y is +1. So that was our Roman letter 2. So I want you to add there a paragraph. You can now add there a paragraph by noting that the correlation coefficient between the securities, normally range. It normally range from -1 to +1. It normally range from -1 to +1. It normally range from -1 to +1. Then you continue on the same by noting that +1 means that the two securities, it means that the two securities are perfectly positively correlated. +1 means that the two securities are perfectly positively correlated, and therefore, if they are combined to form the portfolio, there will be no risk diversification. If they are combined to form the portfolio, there will be no risk diversification or minimization. There will be no risk diversification or minimization. There will be no risk diversification or minimization. Then another paragraph, we say that If the correlation coefficient is -1, if the correlation coefficient is -1, if the correlation coefficient is -1, then it means that the two securities are perfectly negatively correlated. Then it means that the two securities are perfectly negatively correlated. They are perfectly negatively correlated. They are perfectly negatively correlated. And therefore, if they are combined to form the portfolio, and therefore, if they are combined to form the portfolio, and therefore, if they are combined to form the portfolio, if they are combined to form the portfolio, if they are combined to form the portfolio, there will be 100% risk diversification. If they are combined to form the portfolio, there will be 100% risk diversification or minimization. There will be 100% risk diversification or minimization. There will be 100% risk diversification or minimization. Then another paragraph, you note that if the correlation coefficient is positive, 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 then the standard deviation of the portfolio, then the standard deviation of the portfolio will be the weighted average. Then the standard deviation of the portfolio will be the weighted average. Then the standard deviation of the portfolio will be the weighted average. The standard deviation of the portfolio will be the weighted average. So we are saying that if the correlation coefficient between X and Y is positive, if the correlation coefficient between X and Y is positive, to get the standard deviation of the portfolio will be the weighted average. Will be the weighted average, whereby you get the weight of X multiplied by the standard deviation for X. You add the weight for Y multiplied by the standard deviation for Y. We multiply by the standard deviation for Y. So the weight for X, you remember they had said that the proportions had been given for us. They were able to give you the proportions. The question was able to give you the proportions. So remember, the weight for X was 0.2. That was 200,000 divided by 1 million. It has given us 0.2. So this standard deviation for X is what you have up there as 2.2. The weight for Y is 0.8. Standard deviation for Y is 1.1. So when you add them together, they should be able to give you the standard deviation for the portfolio. So standard deviation for the portfolio will simply be the weighted average. The standard deviation for the portfolio will simply be the weighted average. The standard deviation for the portfolio will simply be the weighted average. So that is how to compute the standard deviation for the portfolio when the correlation coefficient is positive. Another paragraph, we note that if the correlation coefficient, another paragraph, we note that if the correlation coefficient is negative, if the correlation coefficient is negative, if the correlation coefficient is negative, then the standard deviation for the portfolio, will be the weighted difference. Then the standard deviation of the portfolio will be the weighted difference. The standard deviation of the portfolio will be the weighted difference. The standard deviation for the portfolio will be the weighted difference. So to get now the standard, if the correlation coefficient, between x and y is negative, if that difference is negative, then the standard deviation for the portfolio will simply be the weighted. It will be the weighted difference. It will be the weighted difference. So if it is the weighted difference, it is the same as the weight of x, the standard deviation for x. But now we subtract. Remember, when it was positive, we added. When it is negative, we subtract the weight of y and the standard deviation for y. So I'm not computing because this question, it was positive. So remember, it was positive 1. But just in case, you will get a question which will be giving you a negative. If you get a question which will be giving you a negative, you will be subtracting. That is, if the correlation coefficient is negative. So now another paragraph, we also note that the actual standard deviation of the portfolio, the actual standard deviation of the portfolio, the actual standard deviation of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio will be calculated as follows. Or the actual risk of the portfolio will be calculated as follows. Or the actual risk of the portfolio will be calculated as follows. Or the actual risk of the portfolio. So to get the actual standard deviation, when you want to compute the actual standard deviation, actual standard deviation of the portfolio, or the actual risk, or simply the actual risk of the portfolio, or simply the actual risk of the portfolio. It is supposed to be given by, so we are in this question, it is supposed to be given by the weight of x squared multiplied by the variance of x, like that. We also add weight of y squared, the weight of y squared, then also the variance of y, like that. Then we also add 2 multiplied by the weight of x, multiplied by the weight for y. We also multiply the covariance between x and y. Then we will be getting the square root for that question. We should be getting the square root for that. We should be able to get the square root for that question. So weight of x squared, variance of x, weight of y squared, variance for y, then plus in brackets 2, multiply the weight for x, multiply the weight for y, also multiply the covariance between x and y. So some questions, may not give you the covariance, but we already know how to get the correlation coefficient. So whereby, in case the question has not given you the covariance, if the question has not given the covariance, correlation coefficient between x and y, remember it is supposed to be given by covariance between x and y, the standard deviation for x multiplied by the standard deviation for y. So we make the covariance to be the subject. We simply make the covariance to be the subject. So if I make the covariance to be the subject, it will be equal to correlation coefficient between x and y multiplied by the standard deviation for x. We multiply by the standard deviation for y. So if you want to get the covariance and you have that information, so that means that in this particular equation, in this part of the equation, the area of the covariance, you replace it with this part. That will be correlation coefficient between x and y multiplied by the standard deviation for x multiplied by the standard deviation for y. So that is also how you'll be coming up with that covariance. That's how we should be able to come up with that particular covariance. So we want to answer the Roman letter 3 of this question. Roman letter 3 of that question, it is supposed to be the portfolio risk. Roman letter 3, they wanted you to complete the portfolio risk. So portfolio risk will be the same as what we have at this point. The portfolio risk is the same as what you want to come up with that way. So weight for x, the weight for x, remember it was 0.2, so you get 0.2 squared. The variance for x, we already have it, but you simply square the standard deviation. That is 2.2 squared. Then we also add the weight for y. Remember it was 0.8? Yeah, so you take 0.8 squared. The variance for y, you take the 1.1 squared. Then 2 multiplied by 0.2 multiplied by 0.8. Then the covariance between x and y, the covariance between x and y, we got 2.4. Then now you can square be able to come up with the square root of that thing. So it has given us each figure. compute, give me the bar.
A to B are used to identify one more.
So someone has given me 1.32. Yeah, it should be the same as the other one because the correlation coefficient is positive. 1. The other one was also 1.32. Now, when the correlation coefficient is positive 1, the two will be the same. The two figures will be the same. So that was meant to be the Roman letter 3 of the question. So now we got the Roman letter 4. We got the Roman letter 4 where they want to get the reduction in risk due to the portfolio diversification. The reduction in risk due to the portfolio diversification. They want you to get the reduction in risk due to the portfolio diversification. So when you compute this figure, you will get 1.32. Now, when you compute, you will get 1.32. When the correlation coefficient is positive 1, the weighted and the actual are the same. The weighted and the actual are always the same. So let us see how to get the percentage of the risk minimization. We want to see how to get a percentage of the risk minimization. The question wanted you to compute the percentage of the risk minimization. So percentage of the risk diversification or minimization it will be equal to the weighted standard deviation of the portfolio minus the actual standard deviation for the portfolio. We also divide by the weighted standard deviation for the portfolio. Then we show it as a percentage. So weighted, it is 1.32. Also the actual, you got 1.32. Also divide by 1. Then show it as a percentage. Then show it as a percentage. So you see it will give you as 0. It will give us as 0. So now we can conclude by summarizing that. Therefore, if security X and Y, if security X and Y are combined to form the portfolio, if security X and Y are combined to form the portfolio, if security X and Y are combined to form the portfolio, then there will be no risk diversification. Then there will be no risk diversification or minimization. Then there will be no risk diversification or minimization. Then there will be no risk diversification or minimization. There will be no risk diversification or minimization. So that was now in relation to that question. So I will give you another question. I will give you another question. I will give you another question. So this one should be in the sitting of May 2016, question 2, part A. Question 2, part A. For those who are online, I'm sending the question to the group. I'm sending the question to the group. So I've sent that question to the group. They will be giving you the past papers. They will be able to give you the past papers. So that question is there in the group I've just sent right now. So let us go through the question. Let us go through the question. So I'm saying the question is for the sitting of May 2016, question 2, part A. May 2016, question number 2, part A. So that question is supposed to read that Biashara Limited wishes to invest in stock M and N. They wish to invest in stock M and N. Expected return for M is 18, for N is 16. Standard deviation is 8 and also 6. Beta coefficient was given, and also amount of money invested was also given. So required, Roman letter 1, the expected portfolio return. Roman letter 2, explain the effect on the portfolio risk if the returns of the stock M and N were perfectly positively correlated. Include suitable calculation. So we start the Roman letter 1, how to compute the expected portfolio return. We simply want to compute expected return of the portfolio. We want to see how to calculate the expected return of the portfolio. How to come up with the expected return of the portfolio. How to calculate the expected return of the portfolio. So expected return of the portfolio, expected return of the portfolio will be the same as the weighted average. It's the same as the weighted average. It's the same as the weighted average, where you get the weight of X. We get, the weight of M, because it was M and N. It's the weight of M multiplied by expected return for M. Also the weight for N, 8 for N. Also expected return for N. So the weight for M was given. That is 1.2 million amount of money invested in M. It is 1.2 million divided by the total. When you add 1.2 plus 0.8 to be able to give you 2 millions. So expected return for M had been given as 18. It was given as 18. Then we add. The other one should be 0.8. 0.8 millions. We also divide by 2 millions. Expected return for N. Expected return for N was given as 16. It was given as 16 like that. So this is the same as 0.6 multiplied by 18 plus 0.4. 0.4 multiplied by 16. So add them together, they should be able to give us the expected return of the portfolio. It should be able to give you the expected return. So I can see 16.8. I've seen a figure. So that was the Roma letter 1. Roma letter 2, the question was asking you to explain the effect on the portfolio risk if the return of the true stock M and N were perfectly positively correlated. So perfectly positively correlated, I explained positive 1. Positive 1, it means the correlation coefficient is positive 1. That means it is perfectly positively correlated. So it has been given. The correlation coefficient is given as positive 1. So what they are asking you to explain is to get the percentage of the risk minimization. They are asking you to get the percentage of the risk minimization. They want you to compute the percentage of the risk minimization. They would like you to compute percentage of the risk minimization. So to get a percentage of the risk diversification or minimization, diversification or minimization, it is supposed to be given by the weighted standard deviation of the portfolio, the weighted standard deviation for the portfolio. We subtract the actual standard deviation for the portfolio. We also divide by the weighted standard deviation for the portfolio. Then we express it as a percentage. So the correlation coefficient was perfectly positively correlated. It was perfectly positively correlated. So that means that our correlation coefficient between M and N is positive. When it is positive, the weighted standard deviation for the portfolio is the same as the weighted average. It's the same as the weighted average. So we get the weight of M, and then the standard deviation for M plus weight of N, then standard deviation for N at that point. The standard deviation for N at that level. So the weights are already given. This one we said 0.6. Expect the standard deviation for M is also given to you in the question. The question had given you a figure of 8. They gave you a figure of 8. Then this is 0.4. So standard deviation for N has been given as 6. So when we compute, that will be able to give us the weighted standard deviation of the portfolio. We should be able to give you the weighted standard deviation of the portfolio. So you are getting 7.2. You get a figure of 7.2. So we also compute the actual standard deviation of the portfolio. We also compute the actual standard deviation of the portfolio. We now also calculate the actual standard deviation for the portfolio. So actual standard deviation of the portfolio, you simply get weight of M squared, variance of M. You add the weight of N squared, the variance of N. We also add 2 multiplied by the weight of M, the weight of N, and the covariance between M and N. Then we should be able to get the square root for that. We should be able to come up with the square root for that level. So the first thing is to get the covariance. The covariance was not given. So I've given the formula for that. The covariance between M and N will simply be given by correlation coefficient between M and N multiplied by the standard deviation of M multiplied by the standard deviation for N. So correlation coefficient was given. It was perfectly positively correlated. It means it is +1. When it is perfectly positively correlated, it means it is +1. Then standard deviation for M has been given as 8. The standard deviation for N has been given as 6. So you compute those figures. You compute those values. So when you multiply 8 by 6, you give us which figure? It is giving us which figure? So to give you a value of 48, it should be able to give you a value of 48. So after that, we now compute the actual. We now get the actual standard deviation for the portfolio. So weight for M, remember it was 0.6, you square. Then the variance for M, the question has given the standard deviation of 8. We also square that figure. Then we also add the weight for M is 0.4, we square. And also we square the 6. 0.6, 0.4. So that covariance is 48. The covariance is 48. So now you come up with that one. So you come up with that value.
In that cases, we create Tabla direction. Where f of xy, is the function whose value is A maximum. Is A maximum. F of xy is the function.
So it is also giving 7.2. It should also be able to give you 7.2 if you compute. So now it means that the percentage. So now to get the percentage, so to get the percentage of the risk minimization, the weighted is 7.2. Also actual is 7.2. You also divide by 7.2. Then you show it as a percentage. It will obviously give you a 0. It will be able to give you a 0. So the question wanted you to explain the effect. So we can now conclude by summarizing that. Therefore, if security M and N are combined to form the portfolio, therefore, if security M and N are combined to form the portfolio, if security M and N are combined to form the portfolio, there will be no risk diversification. There will be no risk diversification. If they are combined to form the portfolio, there will be no risk diversification. There will be no risk diversification. So we shall stop there for today. They will be able to give you the past papers in the course of this week, maybe today or maybe earliest tomorrow. So they will send them to the group for those who are online. Then we shall be using that. So we can stop there for today.